We're going to take a look at all the components of our robot and what systems they belong to. Everything that you see that's this red aluminum here is going to be the chassis. And you can think of the chassis as the skeleton of the robot. It holds everything together. In of itself, there's no electricity going into the chassis, and it doesn't create any mechanical energy, nor does it have any logic tied to it. It's really just a backbone for the entire robot, and it's what holds all the other parts together. Now, the first major system we're going to look at is the drivetrain. And the drivetrain is going to be anything that actuates the robot. In other words, converts electrical energy into mechanical energy. In this case, we have motors that drive the wheels. In addition to that, we have another motor over here, and this is our servo motor, and we're going to be able to attach an arm onto it. So any of these motors, like these regular DC 5-volt motors or the micro servo, are going to be what we call actuators because they allow us to convert electrical energy into mechanical energy. Attached to the motors is this, and this is our next major system, and this is what we call our drive control. Modern robotics is complicated enough to where typically we're going to want to create a separate logic system that's devoted solely for controlling the motors. So as the programmer, we don't have to worry about how to move the motors. We just tell the drive control system that we want the motors to move. And so the drive control system is where we attach the motors to, and it joins the motors to the logic board underneath it. Now, the drive control system also has another important feature. This drive control system is actually designed to prevent what we call feedback electricity from hitting the logic board. So when you send electricity to a motor, it creates mechanical energy, but the process also works in reverse. If I was to actually turn the motor itself and apply mechanical energy to it, it actually creates electricity, and it works like a generator. Now, that electricity that goes back to the logic system is something called feedback, and we don't want feedback because that extra voltage can actually damage the logic board. So therefore, frequently the drive control system is also responsible for isolating the power to the motors from the power to the logic board itself. So that's another important feature of the drive control system. The logic board is basically the brains of the robot, and it's the part that you're responsible for programming. We can attach the drive control system to it. In addition to that, we can also attach sensors to it. It also does communicate with the internet for our cloud features, so therefore that's what our logic system is responsible for. Finally, power systems of a robot typically are going to be battery-based so that they're not tethered in. There are robots that do have to be wired into like a full-on generator or something that is operated off of gasoline or combustion. And the reason why is because they'll probably need a whole bunch of energy to perform any of their functions. So we're talking about larger robots. But most consumer robots are going to be driven off of DC power and use a battery. Now, another system that we have not actually attached to a robot yet are our sensors, and the sensors are going to be important because they allow the robot to respond to the environment. The first sensor that I have here is an ultrasonic rangefinder, and it allows us to determine the distance from an object. And then we also have a thermopile sensor, which is like an infrared temperature sensor. It allows us to read temperatures of something at a distance. And we're going to attach these to the logic board using this other component called a breadboard, which is kind of like a wiring system that allows us to make a lot of different connections to get to the logic board and make the wires nice and neat, and it allows us to share different channels such as power. So those are all of the different components of the robot and how they form the different systems of a robot.